I am Brisa and I'm in charge of operations management.
I'm Teck and I'm in charge of engineering and assembly.
Justin Western and I'm in charge of modeling and design.
I'm Ameeya Watkins and I'm in charge of programming.
And this is our AEV project. Our Advanced Energy Vehicle project was inspired by Wuppertal Suspension Railway at Germany, which is the oldest electric elevated railway with hanging cars in the world. Our primary objective was to design an autonomous vehicle that would run on an elevated track. The vehicle would then stop at a specified area to pass through a gate and then retrieve a payload. The AEV then needed to bring the payload back to the starting point. Our goal was to design an advanced energy vehicle which would perform consistently while having a low power consumption and high energy efficiency. At the beginning of our design process, each team member brainstormed their own ideas and discussed them among the team. The ideas were conveyed through orthographic and isometric drawings that we learned in class. Each design had its own unique advantages and disadvantages. This allowed us to implement the best parts of each design into our final one. With that in mind, the team assembled the initial AEV design. After several test runs, the team observed and recorded its shortcomings. Another design was then assembled, tested, and compared with the initial one. Each design was then graded on a rubric that the team had prepared, where different weights were placed on different criteria that the team decided was most important. This concept screening allowed each idea to be systematically compared with each other so that the team could pick the best design that would fulfill the objective. The second design, aiming to overcome the shortcomings of the first design, had a shorter wingspan, longer propellers, and more balanced base. And the performance test, the new design proved to be more stable and had a more consistent coasting distance. The team then tested two different codes, one focusing on completing the objective while the other focused on energy efficiency. Data was then collected from these performances. The final design maintained several features of the second design, the main change being a new personalized base with any unnecessary parts having been laser cut. This new base would allow for a lower mass for the vehicle as well as an increase in aesthetics. The overall design demonstrated excellent balance and performance. In the final run, the AEV demonstrated to follow most guidelines for the MCR, while also maintaining a clean and balanced performance. While a few inconsistencies remained, it was deduced that a few simple changes to the code would be able to improve such performance inconsistencies. However, the AEV successfully finished its last run within the allotted time. As a group, we figured that there are several takeaways from this, and one of the main ones was working as a team and being able to coordinate with one another, as well as learning to follow the design process and following the codes as well, and constantly being able to check and recheck and troubleshooting with our project. The whole process of doing something such as this project and how engineering really does take a lot of patience and a lot of work. And this Team K.
This
and this
is
is our AEV project.
We did that.